Now we take differentiation of inverse trigonometric functions. In this, you have to know some formula in the inverse trigonometric functions, but anyhow, from first principles, how to differentiate, let us see. Differentiate, first one, differentiate sin inverse x with respect to x from first principles. Now, let y is equal to sin inverse x, we write. So there are two methods. Directly you can do it, or sin inverse can be brought this side if you know the inverse functions. Sin y is equal to x. Let delta x be a small change in x and delta y be the corresponding change in y. So you have got x plus delta x is equal to sin y plus delta y. Below that you write x is equal to sin y and subtract, you get delta x is equal to sin y plus delta y minus sin y. Divide both sides by delta x and take limits as delta x tending to 0. So delta x by delta y, limit delta y tending to 0, here delta y, delta x, and take limits as, now divide both sides by delta y, not delta x, and take limits as delta y tending to 0. So delta x by delta y tending to 0 is equal to limit delta y tending to 0 sin of y plus delta y minus sin y whole divided by delta y. By convention, limit delta x by delta y tending to 0 is what? Dx by dy. So now right hand side we take sin c minus sin d, 2 cos c plus d by 2. That is what? Y plus delta y plus y by 2 into sin c minus d by 2. Y plus delta y minus y by 2 whole divided by delta y. And this is nothing but limit delta y tending to 0 cos 2y plus delta y by 2. This is what y only, it is not delta y. So here in the bracket this y and y cancel. So what do you get? Sin delta y by 2. Sin delta y by 2 by this delta y is already there, and 1 2 which is there in the numerator can be brought in the denominator and so that this becomes sin theta by theta tend to 0. So now use the formula and then write wherever delta y is there you write 0. Cos 2y plus 0 by 2 into 1. That is 2 and 2 cancel, it is equal to cos y. Cos y is what? Root of 1 minus sin squared y and it is nothing but sine y is what? X. Root of 1 minus x squared. So what we want is dy by dx. So dy by dx is 1 by dx by dy, and it is equal to 1 by root of 1 minus x squared. Now we take the second formula, differentiate cos inverse x with respect to x from first principles. So let y is equal to cos inverse x, cos y is equal to x. Let delta x be a small change in x and delta y be the corresponding change in y. So x plus delta x is equal to cos y plus delta y. Below that x is equal to cos y, you write, and then subtract. This is what delta x is equal to cos of y plus delta y minus cos y. Divide both sides by delta y and take limits as delta y tending to 0. So limit delta y tending to 0, delta x by delta y is equal to limit delta y tending to 0 cos of y plus delta y minus cos y by delta y is there. So left hand side becomes automatically dx by dy by convention. So here limit delta y tending to 0, numerator cos c minus cos d, minus 2 sine c plus d by 2, y plus delta y plus y by 2 into sine c minus d by 2, y plus delta y minus y by 2, whole divided by delta y. Now this becomes limit delta y tending to 0, minus sign you leave it there only, sine 2y plus delta y by 2 into big bracket. Now here y cancels, so sine delta y by 2 is there. Sine delta y by 2 by this delta y here, and this 2 in the numerator can be brought to the denominator of the denominator, so that it is in the form sin theta by theta, theta to 0 is what? 1. So this delta y you write as 0 minus sin 2y plus 0 by 2 into 1 because of that formula. So 2 cancels, it is what? Minus sin y, it is equal to minus root of 1 minus cos squared y, and cos y is what? X. So therefore 1 minus x squared, minus root of 1 minus x squared. But what we want is dy by dx is equal to 1 by dx by dy, and that is equal to minus 1 by root of 1 minus x squared.